So before we continue, I want to start putting the code for these online so that if you missed the first few episodes, you can pick up where we left off on the previous video and then just continue. Or sometimes you type the wrong thing in the wrong place and it breaks and you can't find out what broke, so you want to start over. So to be able to download the file from the previous part is not the problem. Downloading is easy. You click on the link, it'll download the file. Problem is, how do you get it into TIC-80? Now, TIC-80 has a folder somewhere on your computer called folder. Well, you type in folder, and when you press enter, it will tell you where it is, but it will also open it in files or in the Explorer or in Nautilus or whatever your file browser of choice is. So here goes. Now, in my case, this is what popped up. So after downloading the file, I go find it in downloads, or I drag it from the bottom of my browser where it shows the file that just downloaded. I just drag it into here and I let go. And then back in TIC-80 is if I list the contents of this folder by either using ls or dir. What's this? The quest.tic file is in there. So if I load quest.tic, I can run it. This is, by the way, one of the little example files that you can load up in TIC by running the demos or demo command. I'm not sure. But most of the stuff that's in that folder is a little bit beyond the scope of what we're doing. So I wouldn't recommend it. It'll scare you, and I'm worried that it'll be intimidating and then people decide not to participate. Anyway, I'm not going to finish this thing. Let me just die here in the lava. You died. Press X to restart. Anyway, and there's the code for that particular game, which means by the same logic, if you were to download the file that's linked in the description and load Pong 2, you will be in exactly the same place that we are. So, now that we are here, what are we doing? Well, last time we had this paddle moving up and down, although not up and down at the same time, but it can boundary break. It can leave the top of the screen. Now the thing is, we're starting to interact with this paddle a lot more than I'm comfortable with having a bunch of global variables just floating around. We're polluting the global namespace. We're going to end up with naming a variable somewhere in our code and accidentally naming it the same thing as another thing, and then it's going to break. So we are going to introduce, I'm making yay hand signs, but nobody can see because I'm alone in my office. We're going to introduce the table, Lua's little power move. Lua does not have complex data types. It doesn't have different kinds of fancy classes and methods and stuff, but what it does have is tables. So we make a table called P1 equals and then braces or curly brackets. That means that this is now an object, or as they call it in Lua, a table. And everything included inside this is included inside the table. So within this table, I can now list a bunch of stuff. So the X location is going to be 2, comma, because it's a list. Y location is going to be 20. I'm retyping everything that's at the top there. Because we're in P1, we don't need to start with P1 because we know we're here, but we can do button up. Notice how this turned green when I was typing it, so I can't just have a property inside P1 named button because it can override things and start breaking things. So we're going to call it button up equals the 0 button ID. Button down is going to be 1. Is that all we need for now? I think that's all we need for now. Okay, now, because of what we discussed earlier, if I now delete these, TIC-80 is going to still run. It'll still run, look. Now, I deleted P1 underscore Y, which it is still reading. So my paddle is now right up against the top and right up against the left, although the 2 pixels on the left here isn't as easy to notice. But if I try to move the paddle, I do believe this is our first error message. Now, we're going to have to explain what's going on here, because you will see this a lot. Sometimes it'll be me, sometimes it'll be you, and you're going to have to figure out what the information is that it's giving you. So, the first part is string title, game title. We need to give our thing a title. Line 27, followed by what went wrong. Attempt to perform arithmetic on a null value. And the null value is the global value called P1_y. Now we know that's a null value because we deleted where we give it a value. So it has no value, thus null. Then it gives you the stack trace. Now, the nice thing about the stack trace is when your bugs become more complicated, this will tell you what was the function that called this thing. Because at this point we know the problem was on line 27, so we can go find the line where it went wrong. But in a lot of cases, the reason it went wrong is because it was called from the wrong place, or it was called correctly but with the wrong values. So we need to figure out where it came from, and that's what the stack traceback does. This first entry is the entry that we have above. So it says it's line 27 in the function inputs. Okay. So we know that something is wrong in inputs, but how did we get to inputs? Well, line 17 of TIC called inputs to put us here. And it'll keep going like this all the way out until you reach usually TIC. It'll reach whatever was the highest level of your code. And the more your functions call other functions, the more levels down you go, and the longer this traceback will become. I've never seen it more than 3 functions recently, at least, that I remember. But that's not important. So, first thing is line 27. Now, you can click on, where is it, that little button? No, that button, the little right arrow, go to, or you can press Control G, G for go to, and then type the line number, 27. There's our culprit. We are trying to subtract a number from a value that doesn't exist. Now, what's happening inside Lua is it's trying to go null minus 1. Now, null doesn't have an inherent value. I mean, if I tell the thing to draw at null, it's going to be 0. But I can't do maths with nothing. So, that's where we get our error message. But we do know where this value is. We just moved it. P1, this is how you reference objects. So we'll leave this line here. Oh, by the way, putting comments in front of a line to quickly stop it from being code is a nice little reference trick. Because if I now decide that I want this line back, I can just take out the comment and it runs as normal. You can also do longer comments by doing the 2 dashes and then the 2 brackets, and then whenever your code is finished, you put the 2 brackets again, and sometimes just because it looks nice, the 2 dashes, to comment out an entire section if you want to take it out and see what's gone wrong. So, we now have, let's quickly go back up to our object. We have an object named P1, and then it has properties. They're not really properties, not the way a table works, but it has things inside them with names. They are called X and Y, and BTN up and BTN upside down up, BTN down. So that uses the dot operator. Here we go. So P1 is the name of the global, and then dot Y gives us Y inside P1. Now there's other ways of doing this. We'll get to them. If you have things with string indices, then it's a key value pair. You'll want to look up by a string key using this syntax. That's a key value pair. There's other stuff you can do. You can call functions in there, but we'll get to that. As it's necessary to understand, I'll explain them. So we need to redo the code at the top, but changing the value of y inside P1, which is like this. And now because I did it here, I also need to do it down here, which the short version is just doing that. Just changing the underscore to a dot. It's almost like I planned it. Okay, but there's somewhere else that we use these values, because here we are changing them so that the paddle moves, but we draw according to those positions as well. So here we draw according to P1.x, and P1.Y. So that should then draw our paddle at the X and Y values that are contained within the P1 object. So P1 dot X and P1 dot Y. Okay, let's see if that works first. Run. You can immediately see that this paddle is now 20 pixels down from the top, and if you look very carefully, it's 2 pixels away from the left edge, because that's where we told it to be and that's what the value says. But now if I try to move it, nothing happens. Why does nothing happen? Oh, that's still the error from before. Run. Nothing happens. Why does nothing happen? Where do we handle button presses? In inputs, right? In inputs, we are checking whether the button P1 underscore up is being pressed. In other words, what our code is doing is it's checking whether the null button is pressed, because P1 underscore up is null and the null button can't be pressed. So this needs to be dot ptin underscore up, because that's the new name we gave it. And then the same for this one, P1 ptn underscore down. Okay, I think that's everything. Okay, we're back in business. We can move again. Okay. While we are here, should we allow the paddle speed to be changed? Because the paddles are kind of slow. So let's add speed and make it 2. So instead of adding 1, we add P1 dot speed, and subtracting, and instead of adding, we subtract. Okay, you get what I mean. So now it should go twice as fast. Whee, that's nice. Which means now if we want to change the speed of the paddle, all we have to do is change this number right at the top of our code, and we don't have to go looking for things. Objects are awesome. I love object-oriented programming. Okay, but we are here to stop this thing from leaving the top of the screen. So it's time to introduce updates. So in our updates function, which is a function, so it needs brackets, updates is going to be in here. They don't have to be in the order that they're called, but while it's possible for them to be in the order that they're called, I like keeping it that way because it's nice and neat. So, because then it goes inputs, updates, draw. It's not going to be like that forever, maybe not even by the end of this episode, but we'll see. So, in updates, we need to check whether paddles have left the screen. So, if p1.y, how do we know when it's at the top of the screen? Because the xy coordinate that we have inside the object is the top left corner of the object, right? Because from there we draw a rectangle that is a certain width to the right and a certain height down. So, how do we check if it's left to the top of the screen? Well, if its y is less than 0, it means it's gone outside the top of the screen, because as discussed previously, the top edge of the screen has a y coordinate of 0. Now, I don't like this, because I feel that it should stop even if it is on 0. But we also have our 1 pixel border at the top. So should we then not maybe stop 1 short? 1. Because then it'll move right up to our single pixel line at the top of the screen, but never actually cross the line. Sure. Start with that. We can always change it. So if P1's y coordinate is lower than, smaller than, or equal to 1. Actually, it doesn't need to be equal to. If it is smaller than 1, then we've gone past the top of the screen. So let's move p1.y to 1. That'll be the highest it's allowed to go. Okay, let's just keep it there for a second. Small changes, make sure nothing breaks. So This is our TIC function. It runs 60 times a second. When it runs, we check inputs, the player is pressing up or down, in this case probably up, and we move the x coordinate for the paddle too far up. Then in updates, we check if the paddle is too high, and if it is, we reset its position. And then we draw it in the correct position, which means we check the inputs, we check the updates, and then we draw. So even if the player moved too far, our code will correct its location before it is drawn to screen. So the player will never see the paddle move too far up and suddenly jump back. That's the important thing. That's when glitches and clipping and like boundary breaks happen in big complicated video games. It's when you move beyond the location of something before the code is able to check. Now, why didn't I just check the location here before moving the paddle? Because then we're getting stuff mixed up, and then we're getting our updates mixed with our inputs. We want our inputs function to be clean. We want our inputs function to only be in charge of looking at what buttons are being pressed and what that does. We want updates to take care of stuff like gravity. There isn't gravity in this game, but in other games there are. Or effects happening. Or later on we'll start looking at animation, although I'll probably move animation into its own separate function. But I don't think this game is going to need that. Okay, that's why this is in updates, because the ball's logic for the ball moving is going to be in updates as well, so we might as well add it now. Okay, so inputs, updates, draw. Inputs, the paddle moves. Updates, it checks if the paddle is too high, fixes it, and then we draw. In other words, if I now run this, did I save? Even if I didn't, I saved now. I'm working over my code number 2. Anyway, let's get the payoff first. If this moves up, boop, it stops right there, and it can't go past. Even if I spam the button, if I hold it in, it is impossible for the paddle to move past our little gray line, because every time it does, its position gets set back to the highest it can go before the screen even draws. Okay, I'm happy with that. But now, more importantly, this is part 3, not part 2. Otherwise, I'm going to write over my own code. You guys are going to hate me for that. So, we also need to check when we reach the bottom of the screen, right? Updates. If it's at the top. Now, it can't. The paddle will never be able to reach the top and the bottom at the same time. So this is a good situation for an else if. Because what will happen is, if the paddle is too high, then we reset it. But if the paddle is still in the play area or low enough, we don't even execute the code that's in the middle. We check this condition, which means if we've got a whole bunch of ifs and else ifs running, we don't need to check all of them one by one. As soon as we find one, it skips to the end. So, else if p1.y is greater than the bottom of the screen. What's the bottom of the screen? What are we going to make the bottom of the screen? Because it's normally 136. Because it starts at 0, it means the bottom row is 135. Which means we need to check if our thing is bigger than 134. Well, no, 135 is fine. The problem, let me just put the then in there so that we don't forget. But the problem with this is, that's going to check the top left corner. So if I now run this, my paddle won't stop here. It can still go all the way down till... Actually, it doesn't stop it at all, because I didn't put the then part. P1.y is equal to 135. Now the problem is, boop, it moves down to there, and then it gets stuck, because we're checking the top edge of the paddle, not the bottom edge. So, when we draw the paddle, we give it an arbitrary height. Paddle 1, height is 16. That number was a thumb suck. If you watch part 1 of this series, you can literally see me try different numbers until I find one that looks nice. But at some point, we might want to change that. And it can be kind of cool if players can have power-ups or whatever that allows the size of the paddle or the speed of the paddle to change. So this is a perfect candidate for a global variable. It doesn't belong to a particular object because the paddles will probably both be the same size. For the time being, let's just make it a single value. Now I like using capitals because then I know, whoa, this is a global variable, need to be careful with this guy. Not width. Height. And we can use that here as well. Not that it makes a difference, because at this point, paddle 2 is literally just a rectangle. It has no code, no logic behind it whatsoever. It's just a paddle that sits in. It's just a white rectangle that sits there. It does nothing. But for our paddle that we're actually using, this is important. So paddle height at this point is null, which is going to cause some weird nonsense. But let's quickly make that. I just copied the name so I don't have to type it again. And it also means I don't accidentally spell it wrong. Paddle height is equal to, what did we say, 16? So this should make no difference to the code. Paddle should still draw exactly the same. I now have the advantage that I can change this to a different number. And the paddle changes. That looks weird. So we know it works. We know that the paddle is being drawn using this height. But what that also means is when we, in updates, check where this paddle is, we cannot check the top left corner, we can check the bottom left corner by adding the height of the paddle to the value and then setting py to the bottom edge of the screen plus the paddle height, which would move it up another, in this case 16 pixels, but we can change that and run. Boop. What happened there? What happened there? There's no error. Oh, that's what happens. Because we are checking paddle height above the border, but then we're setting it to paddle height below. This should be a minus, because it's 135, and then we go back up the paddle height. There we go. That's the behavior we want. Look, it's not going anywhere. Okay, this is starting to look like a game. This is starting to become exciting. Okay. So that's the first basic part of object-oriented thingamadigs. We handled input and draw functions using the object-oriented thing. Maybe it's time we get paddle 2 moving as well. Yeah. Let's do that.